Hi, welcome to Wise Guys. This video is on the addition of vectors, and it's basically a first video on the addition of vectors. So I'm just going to talk a little bit here about the polygon method of trying to determine what the resultant's going to look like. So here we have two vectors. One of them here is moving at about 0 degrees, and then we have a second vector that's moving down to the right. And these would both have numbers on them, which they don't right now, and angles. But what we do is we take vector A and vector B, and we just add them by putting them tip to tail. Here's the tail, and this side's the tip. So we go from the tail to the tip, and then for vector B, we just add it right on here. And then we say, okay, so we started here, we end here, so the resultant has to look like this. So if normally what we do when we have these vectors was we put them on the x and y axis. So here's our A, and here's B, and again you just approximate where B is going to be. And then we just sort of stop and say, okay, what's my resultant going to look like? It's probably going to be over here. There's B. So in the end, I should have this for my answer. All right? And all this is just information before you start adding or subtracting your vectors. Because if you end up with an answer that's up over here somewhere, you can say, hey, you know what? I probably made a mistake. All right, so that's all this is just saying, okay, what should my answer look like? All right, so let's start with a question. Excuse me. So here we're going to add these two vectors, the 10 newtons and at 45 degrees and 21 newtons at 72 degrees. So we start with our x and y axis. We have 10 newtons at 45, so you just approximate. And we're going to call the 10 newton vector A. And this is our 45 degrees. And then we have our 72 degrees, which is here. Or 72 degrees, and it's 21 newtons. And that angle is 72 degrees. Okay, so those are our two vectors, and we're going to add them together. Now you can see we have our 21 newtons going up here, and that's probably not 72, but that's close enough. We just sort of say, all right, what should our final vector look like? We have our 21. We're going to add the 10 newtons at 45. So it's going to look approximately like this. So our final vector should look close to this, all right? This should be about what we'd be expecting to see in the end once we add them both up, all right? So just a reminder, the 45 degree vector, let's just say this one. This is vector A and this is vector B, all right? So what we're going to solve is for the x and y portions of both of those vectors. So vector A, here we are. So we have A here, which is our 10 newtons. We have an angle of 45 degrees. And we want to solve for the x portion. So we're going to call this AX. And we want to solve for the y portion of that vector. So we're going to call this one AY. Now you can see here that what we're dealing with is a right angle triangle. This is A, which is our 10 newtons. Here we have 45 degrees. and we want AY. We can see here AY is here, but it's also the same length of this side of the right angle triangle. So that piece is our AY, this piece is our AX. Okay, so now we're going to use trig functions. If we want to solve for AX is adjacent to the angle, and our 10 newtons is our hypotenuse. So it would be adjacent over hypotenuse, so we would be using the cos. So the cos of 45 degrees equals AX over the 10 newtons. And we manipulate this equation, multiply both sides by 10 newtons, and we end up with AX equals 10 newtons times the cos of 45 degrees. Okay, calculator, where'd you go? Here we go. So we have 10 times the cos of 45 equals 7.1. Let's go with 7.1. So AX is 7.1, that's newtons. AY equals. Now for AY, we can see that we'd be using sine, because this is opposite over the hypotenuse. So AY then would be 10 newtons times the sine of 45 degrees. And that would be 7.1 newtons as well. All right, so now we've solved for AX and AY. Now let's just move on to the next page, and we'll deal with our 21 newtons at 72 degrees. So here's our 21 newtons, and this is vector B. We want to solve for BX, and we want to solve for BY. So again, we're dealing with this triangle. This is 21 newtons. This is BX. This is BY. And our angle here is a 72 degrees. Okay. So, solving for BX, that's our adjacent. That's our hypotenuse. So then the cos of 72 degrees equals BX over the 21 newtons. Therefore, and we multiply both sides by 21 newtons, therefore BX equals 21 newtons times the cos of 72 degrees. So BX equals 21 times the cos of 72 equals 6.5. 6.5 newtons. So there's our BX. And our BY, we can see BY is the sine, so opposite over hypotenuse. So BY then is 21 newtons times the sine of 72 degrees, which equals 21 times sine 72 equals 19.97, so let's go with 20. So BY equals 20. And that's newtons. All right. So, need another piece of paper here. Where have I got paper? Right here. Okay. So now we solve for AX. Let's remind ourselves. AX equals 7.1 newtons. AY equals 7.1 newtons. And BX equals 6.5 newtons. BY equals 20 newtons. All right. So we take the information that we solved and put it here. And then we have our X and Y axis here. So AX, so on the X axis, right? There's AX, and it's 7.1 newtons. And then BX, right here, is 6.5 newtons. AY in this direction, 7.1 newtons. Yeah, that's AY. And BY, right here, is 20 newtons. Okay? So you can see here that on the right x-axis, we have 7.1 newtons added to 6.5 newtons, all right? So 7.1 added to 6.5, that is 13.6. So we end up here with 13.6 newtons on the positive x-axis. Then we add our y vectors. So we have 20 plus 7.1. So here we end up with 27.1 newtons in the y-axis. Now what we do is just the same thing as we did before when we're adding these two vectors. Say, okay, well that's going to go straight up there. And we are going to end up with a resultant that looks like straight, not curved like that, but straight. And yeah, this looks kind of reasonable. And it doesn't have to be perfect. All we need to do is actually solve for it. Excuse me. So here's our resultant. And again, we're looking at a right angle triangle. So we can see here we have our hypotenuse and this side of the triangle and this side. All right. 31.6 is this horizontal piece. The 27.1 newtons basically here. So with this information we could use Pythagoras to solve for this vector. And let's just do that. So 13.6 squared plus 13.6 squared plus 27.1 squared equals, and then we take the square root of that. .3 newtons. So 30.3 newtons. And again, let's just remind ourselves what Pythagoras is. So the hypotenuse, let's call it the resultant here. The resultant is the square root of 13.6 squared plus 27.1 squared. So we end up with a resultant of 30.3 newtons. Okay. Now we also have to solve for the angle. The angle is typically here. We're normally looking for theta along the horizontal axis, all right? So that would be this angle right here. And we can see that we have, for the opposite side, 27.1, adjacent 13.6. So we could use inverse tan. So tan to the -1 of 27.1 divided by 13.6, which equals, so inverse tan 27.1 divided by 13.6. 63 degrees. So 63 degrees, right, equals theta. All right, so then up in this corner, our resultant here is 30.3 newtons, and the angle is 63 degrees. And that would be the answer to this question once we've solved for it, okay? All right. So it's a lot of work, and if you can see that it takes a lot of drawing. I used to use 2 pages at least to solve these questions, and that's normal, all right? So that's been brought to you by Wise Guys. Take care.